Today's problem is swap kth node from ends. Difficulty is medium. Accuracy, it's pretty low, 35%. Average time, it's pretty high, 45 minutes. Those are surprising because it is a pretty standard linked list problem, of swapping pointers. What you would need to do, I mean, the usual way of solving this is you would want to find the nodes. You would want, well, you don't even have to find the nodes exactly. You definitely need to find the nodes just before the nodes to be swapped, because we'll call those previous nodes. You need to find the previous nodes of the two nodes to be swapped, because the next pointers of the previous nodes need to be swapped, and then the next pointers of the actual nodes also need to be swapped. That's about it. Now, there's going to be, you're going to have to handle some special cases where the problem can't be solved for one of two or three possible reasons. I mean, one would be like that k is bigger than the length of the list, so that isn't going to work. What else? You do have to handle the case where you're swapping the first and or last node, because then you're going to have to handle the head pointer. You're going to need some special handling for the head pointer, because the original head pointer is not going to point to the head of the new list. But otherwise, pretty standard problem. You can find the nodes by traversing the list. You could traverse the list twice, find it that way. You could find the nodes actually in one traversal, I think. I submitted a solution where I swapped the pointers, and it worked fine. But it occurred to me that in this kind of a thing, where we're talking about swapping nodes, is it really even necessary to swap the nodes? I mean, what if we just swapped the values, right? So like this one, 1, 2, 3, 4, 5, it comes out to be 5, 2, 3, 4, 1. But what if we just swapped the 5 and the 1? Wouldn't that work? Or this one, what are we swapping? 9 and 10. Could we just swap the values, not the nodes? So that's what we're going to try to do this time. Okay. Let's see. Well, you know what? I don't think I even read the problem yet. Given the head of a singly linked list and an integer k, swap the kth node. That would be a 1-based index. So the first node is, so the first node is this one, the 1. That is the first node from the beginning. First, kth node from the beginning, kth node from the end. Return the head of the final formed list. If it's not possible to swap the nodes, return the original list. All right. List size will be somewhere between 1 and 10 to the 4th, 10,000. The data in the nodes is not really important. K will also be between 1 and 10 to the 4th. Expected complexities, looks like a linear operation, O of n. Company tags, Morgan Stanley, Amazon, if you're planning to interview at either of those places. And topic tags, it's not that helpful. All right. Let's look at this second example here. I need a pen for this. All right, let's start here. So if the head is null, or if head dot next equals null, well, if the head is null, then just return it. There's no list. If head dot next is null, we have a one element list, and there really isn't anything to swap there. So just return the head as well. So first node, we want to find the kth node from the beginning. So let's see, first node is head. Now it's actually here. Head is not an actual node. It's just a pointer. So it doesn't count. It doesn't count as a separate node from the first node. So the first node is right there. For I equals 1, I is less than k. In this case, k is 2. So we're only going to go through this one time. If first node equals null, return head. That means if k is actually bigger than the length of the list. So you're looping here, looping, incrementing first node equals first node next. But at some point, you just go past the end of the list because k is bigger than the length of the list. Now, if that happens, then that is a case where we can't do the swap and we just return the head node, right? Otherwise, we go through here one time and first node equals first node next, all right? So this will be, I'll put an F there for first node, okay? Second node equals head. Okay, so yeah, let's do that. So here's the second node. Now, temp equals first node. Okay, good. So here's temp. We can use temp to find the kth node from the end by moving temp to the end, while second node moves to the kth node from the end. So that's what this while loop is doing. We're going to move temp and second node until temp dot next equals null. So that would be this node here. We would need to move t all the way down here. Temp dot next equals null. Now, if we do that, then the S node would follow as far as here. Okay, so now we have the first node and we have the second node. And that's it. So we just swap them. Temp equals first equals second equals temp, return head. So yeah, all we would do is put the 9 here and put the 10 here. No pointer swapping at all. And I can't see why this wouldn't work, right? Let's get rid of some of the writing. Let me do a quick sanity check on this. All right, well, that worked. Okay, let's go. Okay. That's it, 2 out of 3. Did I get one wrong? I guess I must have gotten one wrong at first. But I did submit a pointer swapping solution that worked. And so that's, I mean, that's it. You can easily find hundreds or thousands of solutions to this online where pointers are swapped. If you want to see one, you can probably figure it out yourself. But yeah, go, please like the video. It's kind of a new algorithm for swapping linked list nodes without actually swapping the nodes. And you can subscribe for free, and I'll send you problems of the day in right into your inbox. It's free. I think I already said that. All right, that's it. We'll see you next time.